Hello everybody, my name is Chris Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site. And this presentation is about the Boeing Business Jet, known as the BBJ. So I'm going to be covering the brief history, talking through the different versions of the BBJ, and then most of this presentation is going to be about the differences from regular NG or MAX 737s. So with that, we're going to be looking at the completion process, winglets, performance considerations, cabin interior, comms and IFE, fuel, air systems, HUD or EVS if installed, and various other FMC options and other miscellaneous options. As always, please treat your company training and their manuals as the authoritative source of information. Okay, so let's have a brief look at the history and background of the BBJ. So the story goes that back in 1996, the then CEO of Boeing, Phil Condit, was having dinner with Jack Welch, who's the CEO of General Electric. Jack was considered buying a Gulfstream 5 for long distance trips, but thought it would be too claustrophobic for the very long journeys. Anyhow, excuse me, Condit took this idea back to his then VP Product Strategy, Mr. Boris Boskov, and asked him if the new, because again this is back in 1996, so the NG was just coming about then, so asked if the new NG could be made to match the 6,000 mile range of the Gulfstream 5, which was a big ask at the time. Anyhow, within a week, Boskov had a solution which involved using the 700 fuselage and the stronger 800 wings and landing gear, plus adding in some auxiliary fuel tanks. Boeing and GE then formed ran with this idea and formed the joint partnership company Boeing Business Jet and appointed Boskov as CEO of it. The joke is that the acronym BBJ actually stands for Boris Boskov Jets. And the BBJ flew in September 1998, so only a couple of years after the idea was first thought up. Boskov quickly realised that the customers he needed to attract were not regular airlines. You know, these are high net value individuals and small sort of bizjet operators. So I say that they're not the people that Boeing had always been used to dealing with. They didn't have big, if any, flight ops or engineering departments, and needed to be treated differently. So Boskov managed to convince Condit that BBJ needed to be independent of Boeing in order to work, to give these customers of theirs the special treatment, the individual attention they needed and expected as people of this wealth. BBJ got its independence, and with this its own identity and culture, and success followed on from that. The BBJ company, which obviously is still going, they also provide maintenance and warranty agreements with 24-hour customer support worldwide. Routine parts are provided by next day shipment service and a 2-hour shipment service for AOG orders. So they really do look after their customers at BBJ. By the end of 1997, so after the first year of sales, the BBJ had already got 29 orders, which was double the original estimate. The first two of which, of course, went to General Electric, as per the conversation with Jack Welch. To date, over 150 BBJs have been ordered. The breakdown is approximately 40% for private individuals, 36% for government heads of state, and the rest for corporations and jet charter operators. So let's have a look at the different versions of BBJs. The first one actually wasn't a BBJ as such. The first VIP 737 that Boeing ever built was back in the 1970s, and this was based on the 200, and it was known as the corporate 7732, or well, it had various names, the corporate 200, and the 737-200 executive, which was kind of the last name that this settled on. Many of these were sold to governments, but some were sold also to private customers. And essentially, this was an executive jet version of the 200 and 200 Advanced. The aircraft usually had long-range nav equipment, which I think back then was Loran or Decca. No, I think it was Loran, and auxiliary fuel tanks to give a maximum range of up to 4,000 nautical miles with an 1,100 kilo payload. So again, similar sort of design concept to the BBJ. It was, long range, hence needing long range nav and fuel tanks, but with reduced seating, hence a reduced payload. So the first BBJ proper was the BBJ-1, and this was actually certified as the 737-700 IGW, the increased gross weight version, and that's still the sort of overarching Boeing identity of the aircraft. The BBJ-1's got a max takeoff weight of 77.5 tonne, or 171,000 pounds, compared to 70 tonnes for a regular 700. So it's a 7.5 tonne increase in max takeoff weight. It's got the 800 brakes, for better stopping capability, and since October 1999. 27k thrust, which is shown in that FCOM performance in flight extract right there. That, of course, isn't standard on the 700. The next one up, which is based on the 800, is the BBJ-2. This one in this photo looks quite similar to any other 737-800, but there are a couple of differences. The overwing exits, if you notice there, one pair are greyed out, if you like, so you don't have that contrasting paint outline which you need by law for an emergency exit. That tells you that emergency exit is deactivated. And the reason they can do that is because it doesn't have the passenger capacity of a regular 800. So they, one pair of overwing exits are deactivated. Some BBJs, one or both of the rear doors are also deactivated, as they might have bathrooms or bedrooms against them at the back. And in most cases, the emergency exit slide lights are also deactivated for those applicable doors. So, as I say, it's basically an 800. Being a longer aircraft, it's got 25% more cabin space and twice the cargo volume or auxiliary fuel tank capacity of the BBJ-1. And finally, for the NG series, you got the BBJ-3, which is based on the 900ER. This entered service in 2009. It's got one pair of overwing exits, like the 800, what with the other pair being deactivated. And often the rear doors deactivated, again like some 800s. The other thing which is deactivated, and you can see it on the bottom photo but not the top photo, is the mid-exit door, and that's deactivated again. You can tell because it hasn't got the contrasting paint around it. A plug mod for this was available from 2015, which actually isn't fitted in either of those two photographs there, and you can tell when this plug mod's fitted because it's got a standard passenger window there. BBJ-3's got 1,120 square feet of cabin space. That's 11% more than the BBJ-2 and 35% more than the BBJ-1. Range of over 5,400 nautical miles with 5 auxiliary fuel tanks. Then there's the Max. So these are up and running already. The nomenclature for the MAX BBJs is BBJ MAX 7, BBJ MAX 8 and BBJ MAX 9 rather than BBJs 1, 2 and 3, which was used on the NG family. So it's a little bit more logical, you know, it kind of points more directly to the version of aircraft or the version of the 737 it was based on. The BBJ MAX 8's got a max takeoff weight of 82,190 kilos with 7 auxiliary fuel tanks. That gives it a range of 6,640 nautical miles. First one of these was delivered by Jet Aviation from completion in June 2021, and there's been about 20 or at least 20 that we know of BBJ MAX orders placed to date. The orders for these are generally a little more a little less well known than for regular airline 737s, as the customers try and keep these things quiet. The MAX 7, which obviously hasn't entered service yet, but it will be quite soon behind the entry into service of the regular MAX 7. This is slated to be the longest range BBJ ever and should have a range of around 7,000 nautical miles. That's with just 8 passengers and 7 auxiliary fuel tanks, so obviously quite a low payload to get that fuel on. The max takeoff weight is 80,286 kilos, which is the same as a regular MAX 7. Unlike the BBJ1 and BBJ2, there are no structural strengthening differences between the BBJ MAX 7 and BBJ MAX 8. So that all regular MAX 7s and hence BBJ MAX 7s are going to be have the structure, the strengthened wing of the larger 8. First MAX 7 was ordered in 2016. Okay, a little word about block numbers. I haven't mentioned these in any of the previous videos, but for those of you who are involved in the technical side of fleet management, or indeed have access to, you know, service bulletins or maintenance manuals or what have you, you know the effectivity of Boeing technical documents always refers to aircraft in terms of block numbers, also known as variable numbers, and these are used by Boeing to identify a series of aircraft built to a similar specification. Unlike the registration, the block number stays with the aircraft for life, a bit like the serial number or the construction number. It's also got more meaning than the construction number or the line number for identifying aircraft, because it narrows them down to those which require a similar, you know, sort of future treatment. If you think about it, construction numbers are basically just sequential, or line numbers are sequential from the first NG or MAX right through to the last one, and it takes no account of what series of aircraft or what version of aircraft it is. The block numbers actually do. That's where they're different. So for the BBJs, block numbers. So for BBJ1, the Yankee Golf. For a 2, it's Yankee Delta. For a 3, it's Yankee Hotel. And for the MAX 7, it's 1 Echo. MAX 8, 1 Charlie. MAX 9, 1 Delta. So you can see there's a bit of sort of chronology there with the Maxes, because the MAX 8 was first to fly, so that got 1 Charlie. Then the MAX 9 next, 1 Delta. Then the MAX 7 came last, which is why it's 1 Echo. It's always followed by 3 numbers, so I've just shown it as XXX there, where they're the specific aircraft number of that block, as you can see in the examples I put on the right hand side. So let's get on with the differences from regular commercial 737s. Most of the differences are basically the optional extras that are things that you have to pay for with an airline specified 737, but they just come as standard on the BBJ. I mean, I guess you do indirectly pay for it, but whereas the starting point on an airline 737 is it's bare, you know, it's almost green, and the airline then has to, you know, specify what equipment it wants on it. So you build it up from a baseline. With the with the BBJ, you kind of almost build it down from being fully spec'd. You then, if you wanted to, decide which bit you don't need. But most BBJ operators have it with all the works, the full trimmings. So as a result, when you go on a BBJ, if you ever get the opportunity to fly one or get on one, you'll see that you've got a lot of features on it that you don't see on a regular NG or Max. I mean, they are available in isolation on regular NGs or Maxes, but you don't usually see them all together unless you're on a BBJ. The rest of the differences are additional features provided by third-party STC holders rather than by Boeing. So they're things like the auxiliary fuel tanks and, of course, things like the cabin furnishings and equipment. So, a word about completion. When the aircraft is built by Boeing, it's built green, which is a phrase. Green's kind of got two meanings really. One, as you can see from the top photo, is it is physically actually green. The other thing is it means new. And both meanings are apt for a brand new aircraft that's just rolled off the production line. So what happens is Boeing build it and it rolls off the line looking like that, green. The aircraft has got no interior furnishings whatsoever, other than just the forward lav, which is needed for the crew to ferry the aircraft away. So it gets flown away from Boeing Field off to Georgetown, Delaware, where a loft, which you may know as PATS, which was their previous name, are based, and they fit the auxiliary fuel tanks. They can also do EVS, which I'll talk about later, and the low cabin altitude modifications if required. But you as a customer can choose where you get those done. But basically, PATs are the experts. So it's kind of standard that's where you take it to. That work can take up to 3 months, depending what you're having done. If it's just the auxiliary tanks, it'll be a lot quicker. If you're having the EVS and the low cabin altitude, it will take a bit longer. So that's the first stop after it leaves Seattle. The next stop on is completion. So after the auxiliary tanks are put in by a loft, the aircraft is then ferried to a completion centre. There are only about half a dozen or so of these in the world because they're very, very specialist. The main ones are Lufthansa Technik in Hamburg, Jet Aviation in Bâle, AMAC in Bâle as well, Associated Air Centre in Dallas, Comlux in Indianapolis, or Asalam Aircraft in Riyadh, and they will install the custom-built interior furnishings. So stuff like obviously all the fancy seats, all the gold plating, all the the widescreen TVs, as well as stuff like SATCOM and IFE, and they can do the final painting for you as well. That finishing process can take up to 18 months, so way longer than it ever took to build the aircraft. And not only that, it can cost a similar amount to the cost of a basic aircraft as well. So you can kind of the aircraft sort of doubled in value after its finished completion, and doubled in price as well. After that, the aircraft then gets a series of check flights before release to service. Now, the first one is the completion shakedown flight. Now, this is the one that's normally done after the aircraft is built. So it's the first one after it rolls off the production line at Boeing. So this is happening, quite a ways down the track now. Potentially 18 months or so after the aircraft was built, but that's because of all the modification work that needed doing. So this is actually conducted by Boeing test pilots. And for this, all of those recently installed third-party STCs are deactivated for this flight, so the Boeing test pilots can test it against the Boeing baseline specification. So that's done by them. That as usual takes couple of hours or so. They land, they get off. Then the next flight are the STC certification flights. Now these are quite long flights, and these got personnel from the STC design organisation on board. They will check for things like noise levels, vibration, electromagnetic interference, the auxiliary fuel tank operation, which again is why it's quite a long flight, because they have to check all of those work. And on these long flights, the water system doesn't freeze. So all of those things, basically making sure that the aircraft is fit for service, and all of the STCs they put in are all fully functioning. When those flights are complete, often then the aircraft's sent for painting while those STCs are being approved by the authority of registration, which can take a week or two. So use that time productively, get the aircraft painted then, and then after that, once everything, once the STCs are all approved and the aircraft's painted, then there's a final check flight. Now this is the customer acceptance flight. Usually done by the customer tech captain or senior pilot of the outfit that's going to operate the aircraft. And say, having done hundreds of these things, basically everybody wants to get on board for these. Yeah, and you have to be a bit firm about who you exclude from the flight. Especially if you're doing anything fairly significant in the way of air test items, like manual reversion or engine shutdown and relights. So so you carefully choose what observers are on board. These guys fall into two camps. They're the ones from the STC organisation or previous owner if it's coming second hand, and then they are all basically trying to say how good and how perfect the aircraft is, and then there's your team, which are busily looking for defects and imperfections, and the whole thing's a haggling process. You find a defect in the trim, then it might bring the price down a little bit, or you get it repaired, or made good. Whatever whatever you agree on between yourselves. But this is your last chance to make sure you get a perfect aircraft, or your last chance to haggle the price down if that's your motivation. And so it goes on. And once that process is finished, then that's it. You sign for the aircraft, you hand the money over, and it's yours. Normally the age of an aircraft is measured from the date of its first flight, but and that's normally within a day or two of when it rolls off the production line in Seattle. But with BBJs, as we've seen, after production or green delivery, it can take up to 2 years in completion before entering service, during which time all it's done is a ferry flight. Well, 2 if you include the one to Pats. So for BBJs, the age of an aircraft or the year of manufacture starts when the completion and the associated check flights are finished, and that's known as the entry into service date, or the EIS date. And you can see on the example I've got there on the right hand side of a glossy brochure of a BBJ for sale. It's actually quoting there the entry into service date was the first quarter of 2001. So that aircraft was probably rolled off Boeing production line in '99. Making that probably one of the very, very first BBJs ever built. Now you come to look at it, but that's entry into service date. That's what it means. It's not when the aircraft came off the production line, as it is with all normal 737s. It can actually be a couple of years later than that, but it's when the aircraft first started working. So it's a fair description of the age of the aircraft. Okay, winglets. Now, you have to remember that winglets were never a thing on the 737. We look at any 737 now, and it's really quite unusual to see one without winglets, certainly an NG. Winglets were designed by this chap in the photo, Bernie Gratter of Aviation Partners Boeing, and he was the former head of aerodynamics at Boeing. And then he left and got this private job, which must have done his retirement fund the world of good. Anywho, they were first flown. They were actually flown on a regular 737. Well, on one of Boeing's prototypes, a 737-800 in June '98. But it was always as a test bed for use on the BBJ. The winglets were never designed for mainstream airline operators NGs. So I'll say that again. Winglets were never designed for regular NGs. They were only ever designed for the BBJ. Now, of course, they're on every 737 you see, but back in the beginning, they were only for BBJs, and this is kind of why, and the backstory. So the initial purpose was, according to Boris Boskov, say president of the BBJ and the father of the BBJ, he described them as to give the BBJ a look that will set it apart from other business and commercial jets of its size. We want the BBJ to stand out, and we want it to look distinctive amongst all other business jets. And again, you've got to cast your mind back 25 years when winglets were not a common sight at all. Very few aircraft had them. According to the BBJ chief pilot, whom I had the pleasure of meeting, Mike Hewitt, Boeing initially put winglets on the BBJ to enhance the aircraft's image. But once they put them on, they soon learned that the benefits were tremendous. And he said that the performance improvement from the winglet allowed us to pull out the 10th fuel tank, 10th auxiliary fuel tank, as well as enhance the aircraft's hot and high performance. So basically putting this cosmetic item on the aircraft gave huge performance benefits, which of course is why we've all got them now. And the graphics on the right there, these are both courtesy of BBJ. The top one is the original 1998 BBJ brochure, and there's no winglets on it. But as early as 1999, in the 1999 brochure, winglets have appeared. So that was when it all happened. Now, APB, who are based in Seattle, on the same airfield as Boeing actually, were formed in 1999 to sell and market the original blended winglets. So a joint venture between Boeing and APB, an API, to form APB. So API owned 55% and Boeing owned 45%. So API still had the sort of casting vote, if you like, the majority shareholding. APB's got all retrofit rights and Boeing's got all of the new aircraft rights. That's how they divvied out the workload, which served APB very well in the early days. But later on, as more airlines started wanting them building with winglets, then of course most of the work then started falling to Boeing. Certification for the winglets came under the guise of the 737-700 IGW. Remember what I said, the IGW is the overarching sort of family which includes the BBJ and the 700ER. That happened in August 2000, and all the other models followed over the following year. This photo here shows an early 737-700ER. So it's the long-range version for an airline. So it's not quite a BBJ. It's a 737-700ER for all Nippon Airways here. It's their sort of business jet. And that hasn't got winglets because it was initially not certified for winglets in production. Since the ERs, like the BBJ, it's derivative of the IGW, the winglets couldn't be fitted during production. So the first task after the aircraft was built was to retrofit the winglets before delivery. So it was flown off for them to be retrofitted. It seems crazy, but that's how it had to be done. That got resolved anyway in July 2001 from line number 882, when the BBJ, the all IGW family got certified for production rather than retrofit winglets. And just throw this photo in here, taken on a gloomy day in Luton, where you see a lot of BBJs passing through. But the point there is that BBJs, like the rest of the NGs, can be retrofitted with split scimitar winglets. Now, some BBJs, notably early ones, pre-line number 778, have got 2 additional steps in their emergency descent procedure. And I've highlighted them there. The first one is to limit the airspeed to decimal 8 or 270 knots indicated, and then put the gear down. Then initiate the descent. And I've never seen a written explanation for this, but my theory, and if anybody knows better, let me know. But I strongly believe that this speed restriction was a wing strength limitation due to the early BBJs not having the strength of wing required for winglets. The gear down step is to compensate for the reduced rate of descent at the lower descent speed, because normally we do an emergency descent of MMO VMO. You can't on this because you got the speed restriction. If you have to get down within a certain amount of time by certification. The only way you can achieve that is if you're operating at reduced speed, is to increase the drag. That means throwing the gear out. So that's what those 2 extra steps are for. Now, following on from that, the BBJ, and in actual fact all 737s with the winglets, kind of went through various stages before they got to full production winglet installation. So there was a phasing in of the process into the build mechanism, into the build process. So the very first 737 NGs, winglets hadn't even been dreamt up. So the winglets were just not a thing then. A couple of years later, when the BBJ appeared on the scene, and Bosch said stick winglets on it, then the aerodynamicists said, okay, we've got to strengthen the wing for that. Winglets increase the forces on the wing, and I go into this in great detail on the winglets video for those who want to know more about it. That therefore requires, so they require strengthening before they can be fitted. So before line number 778, so these were the ones which were never intended for winglets. The 737 was built without any provision for winglets. So before they could be retrofitted, the wing had to be modified with strengthened stringers and new outboard skin panels and all kinds of things. Those aircraft, so before line number 778, they required the low alleviation system and the 270 knots gear down emergency descent procedure. That's the one in the top of the 3 photos up there, or diagrams, sorry. From line number 778, the wing was built provisioned for winglets by having a strengthened wing box during production. So that can be done. You can't strengthen the wing box really as a retrofit. The cost would be prohibitive. But in production you can. So those aircraft still require the 270 knot gear down emergency descent procedure, but not the load alleviation system. And then from line number 882, which is about 2001 onwards, further strengthening was applied, and neither the load alleviation system nor the 270 knot gear down emergency descent procedure was required. So they're the ones that by and large we fly today. So that's the 3 stages and the 3 things you could find on an early build NG, particularly an early build BBJ. Following on from that, the BBJ-1 has got the strengthened wing of the 800, as we know, to enable it to operate at higher weights than a regular 737-700. Because it's got the strengthened wing, the flap limit speeds of the BBJ-1 were increased to those of the 800. Same wing, same flap limit speed. So one subtle difference for a BBJ-1 over a 737-700 is that your flap limit speeds are higher. Okay, let's talk about some of the performance considerations. For those of you that only fly one series of 737, you probably know or have a fair idea what your V1 MCG is. Well, certainly you should do. Now, If you look at these two tables that I've reproduced here, the top one is for it's called a 737-700 BBJ with winglets. So the point is that's a BBJ, so it's got all the wing strengthening and what have you, but it is a 27k thrust aircraft. The bottom table is a 737-900ER with winglets, and that is also 27k thrust. And if you look at the V1 MCG at 20 degrees mean sea level, you'll see that there's a 20 knot difference in the VMCG, even though they've got the same engines. And the difference is that the moment arm from the rudder to the C of G are different. It's basically your BBJ's much shorter aircraft, or the BBJ-1's a much shorter aircraft than the 900. Doesn't have the same moment arm, hence it's got the low V1 MCG. So that's something to be borne in mind, and that can be limiting. Following on from that, this same effect, coming from a high engine out asymmetric thrust combined with a short rudder moment arm, this gives the high V1 MCG, as we've just seen on the previous slide, but it also therefore gives the BBJ-1 minimum takeoff weights when operating with 26 and particularly with 27k thrust, and you can see those figures marked there on this BBJ AFM on the right. If the takeoff weight is too low, the takeoff speeds will be below, or could be below, V1 MCG stroke VMCA, which is not permissible. There's no such limitations on the long body 737, so your BBJ-2 is fine, your BBJ-3 is definitely fine because the moment arm to the rudder is greater. But for BBJ-1s, that's something that you have to look out for. Another performance consideration that this is more of an option than a thing to look out for, is an option that Boeing have made available since 2000 called alternate forward C of G. It was brought in for the BBJ and for 700s that were going to operate into hot and high airfields. I think there was one, they did trials on one that was going to be used in Bhutan. But anyway, this option's available on other models, but the benefit is greatest for the short body aircraft due to the reduced risk of tail contact and associated VMU, minimum unstick effects. Now, I'm not going to go into the theory here. I'll do a separate video on this in next month or quite soon, and I'll cover all the theory of this and how this works and why it works in a separate video. But for now, what I'm just going to show you is how this is used in BBJ operations. So by using the AFM alternate CG takeoff performance option, the operator can opt to use one of two specified forward CG limits. Well, I mean, it's one of two new limits, 3 limits in total. So these two new limits are further aft of the forward certified limit. From that, you can get better takeoff performance. And as I say, see my video on the subject for the details about how that works. The standard 3 forward CG limits for the BBJ-1 are as follows. So the standard envelope limit is 9%. That's always there. That's how it rolls out the factory. If you take the option, you can have forward takeoff limit 1 of 14% or forward takeoff limit 2 of 18%. Or if you want, if you have got the data to find out where you want your limits to be, you can specify your own limits, and Boeing will draft you up an AFM supplement to represent the two new forward limits that you want. But the off-the-shelf figures for a BBJ-1 are 14% and 18%. The limits are different on the BBJ 2 and 3, and indeed the Max 789, because of the aircraft have got differing performance and different tail contract geometry. But the off-the-shelf figures are these. So how do you use it? If after you've done your weight and balance calculations and the actual Mach tow is say 25%, then you can use the next forward limit, which in this case will be 18% for your takeoff performance figures, which is a huge increase over the standard 9% that you would have to use. And that will give a significant improvement in takeoff performance. If you've done your weight and balance and the Mach tow comes out at 17%, so in other words you're just ahead of 18%, then you can use 14% takeoff performance figures. And again, this is a lot better than the default 9% with associated improvements in takeoff performance. If your actual Mach tow was 12%, then you've got to use the regular forward limit there of 9%. So to summarize all that, using CG limits which are aft of the conservative forward limit location specified by the standard AFM, you get a reduced drag, and that lowers the stalling speed, thereby increasing takeoff performance. Benefits from that you will get: increased max takeoff weight, higher assumed temperature, lower V1, VR and V2, shorter field length requirements from your low V speeds, better margins to VMBE and tyre limit speeds, and often, but not always, greater climb capability as well. So there you go. That's an option that is available for BBJs. Okay, so let's have a look at the cabin interior, which is probably internally the most obvious difference of a BBJ to a regular 737. These are, of course, luxurious. I mean, I could show you dozens of photos of pure opulence on the on BBJs. If you're interested in seeing these, because obviously this is nothing we're able to normally see, then Google BBJ for sale, and you will find details from agencies who are selling BBJs, and often on there you get some interior photographs, and some of them are amazing. I mean, this one I don't know why I chose this one really. It's relatively understated, but some of them are absolutely palatial. Anyway, these interiors, it's not a case of anything goes. They do have to be thought through because they have to be certified for flight safety. So all of these interiors have got their own STC. The design has got to make possible securing loose articles for takeoff, turbulence and landing, and that really is the main limiting factor, other than perhaps weight and balance. I guess you can't have too much weight at one end or the other, but assuming weight and balance isn't an issue, it's the loose objects which really are a clincher. Things like that vase of flowers on the table there, if that was some designs might have a permanent vase of flowers there, so the vase would actually be screwed to the table, and then the cabin crew would come through and remove the flowers for takeoff and landing, and then put them back in again once you're airborne. And obviously all the crockery and the newspapers would have to be cleared away. I'm not quite sure about the soft cushions. I don't know. I would imagine they wouldn't be seen as too much of a they couldn't create too much damage. But anyway, so let's take a look at passenger capacity on the BBJs. Now, I've already alluded to this when I spoke about the deactivating of the overwing exits and sometimes the rear passenger doors. You can't do that without reducing the maximum stated declared passenger capacity on the aircraft's AFM. So each BBJ has got its own individual maximum passenger capacity. You can't say a BBJ always has a maximum passenger capacity of 19 or 30 or 70 or whatever the heck it might be. They are all different. They're all unique. And it's specified in the AFM, well, the AFM supplement for the executive interior. And it's actually often written as 19 or whatever the number is, TT&L. TT&L stands for taxi, takeoff and landing. And some seats are specified as crew only, so jump seats. Some are specified as TTL, i.e. only usable for taxi, takeoff and landing, and some are actually specified as not for use during TTL, i.e. some beds or divans. So they have to remain unoccupied during taxi, takeoff and landing. The rules do change slightly differently for this, depending whether you're operating on commercial or private rules for the particular flight. But anyway, you can see on the right-hand side some examples of this. Now, these are all from the same aircraft, that one that I've shown the floor plan of in the middle. And you can see that the interior is certified for 16 passengers TTL. And in the centre one, it shows a 2-place TTL berthing divan and a 4-place TTL berthing divan. And at the bottom in the office area, there's a 2-place berthing divan which is not certified for TTL. So that one has to remain vacant for taxi, takeoff and landing. So that just shows that some of the subtleties that we don't encounter with a commercial 737. Now, 19 passengers TTL is actually a very common maximum passenger capacity for the BBJ, and the reason for this is that if you operate with 19 passenger or fewer, then the aircraft can be operated under FAR Part 91 rules, which are the general aviation rules. In addition, of course, to Part 135, which is commuter and on-demand rules, depending, where the aircraft sort of, I'll say commercially operated or owned privately. With a declared maximum passenger capacity exceeding 30, then the aircraft has to be operated under Part 121, which are full commercial rules. They're more onerous, a lot more stringent, a lot more hoops to be jumped through, what have you, with associated cost and not only cost, a limiting of what you can do in, well, say for instance the cabin. Also, EASA recently changed the ETOPS rules, as you can see in that second highlighted in yellow extract at the bottom right there, so that commercial operators with 19 seats or less can now fly 120 minutes from an adequate airport without approval, regardless of weight. So that now includes the BBJ. So as long as you've got 19 seats or less in your BBJ, you get a free 120-minute ETOPS approval. So there's another good reason to contain it down to 19. Okay, so moving back to the cabin. Cabin management systems. There are several different ones of these. The screenshots I'm showing you on the right there. That's a system by Associated Air Centre, now Astronics. And this is used by passengers to control the lighting, environment, and the in-flight entertainment. And there's a whole load of selections that the passengers can make on there. The maintenance page I've just shown you there down at the bottom right, that's not normally accessible to passengers, and that's basically for maintenance to troubleshoot, the internet connections, power outlets, supplemental heat, water, humidification, zonal, all those kind of things. This is a different system. Does the same sort of thing. It's a little bit later, this system, so it is actually more capable and more versatile. This is by Collins. It's called the Venue Cabin Management System, and this, rather than being mounted in a fixed place in the cabin, the passengers and crew can download the app for this, so they can access it from their iPhones or iPads or what have you. Again, like the previous system, you can control the cabin lighting, the window shades, the temperature, all the usual environmental stuff. But in addition, you can get airshow system for moving map displays, stage, which gives on-demand movies and TV, and tailwind, from which you can get live satellite TV. And all of this stuff can be shown again either on your personal electronic devices, your own iPads or what have you, or the big displays in the cabin. You can project these things to wherever you want. So going on to comms and the IFE, looking at the systems in a little more detail. The BBJs have, of course, always had state-of-the-art IFE for their time. The key word being for their time. And if you think BBJs first started appearing on the scene in the late 90s, you cast your mind back to what technology was like in the late 90s. Well, it looked like that picture on the right, where you've got a VHS player, a CD, and DVD players. So what was once cutting edge can soon look very dated. I mean, early BBJs had fax machines, and I'm sure there must be somebody watching this video who has never even heard of a fax machine. Yeah, well, it was I know, go ask your dad. Modern systems, of course, now use satellite data for streaming stuff. The systems like this in this photo are no longer built into BBJs, and are probably being ripped out at a great rate of knots and replaced with satellite systems. Satellite, of course, far more expensive. Satellite data tariffs are not cheap. I mean, you think roaming charges on your phones are expensive when you're going around, around the world on night stops. Satellite data tariffs are eye-wateringly expensive. But to be honest, if you're owning a £150 million BBJ, you're not deterred by satellite data tariffs. So if money's no object, then go satellite. So how do they go satellite? You need antenna, amongst other things. There's two main satcom antenna mounting locations, the fuselage and the tail. So looking at the fuselage ones first, in this photo, you've got there an L band and that's probably a KA band on the right. There's KA and I think KU band as well. So these domes, they look huge. The manufacturers say they've got a fuel burn penalty of only 0.04%, and I got that off the CMC Electronics datasheet. They must have proved it to be able to put that figure in print, but to me it looks like it'd be more than that. Anywho, these are high gain electronically steerable phased array antennae. So electronically steerable, so nothing actually moves. It's all done with electronics inside the dome. The steering mechanism is known as a BSU or a beam steering unit. That helps give seamless coverage independent of aircraft direction and attitude. They say over more than 90% of the specified Inmarsat hemisphere. So basically it enables you to keep your signal. This is the tail-mounted solution, and this is from Lufthansa Technik. It's called the 2-in-1 solution, or TIOS, and more latterly it's been the 3-in-1 solution, which luckily for them also begins with the letter T. So that's the TIOS Plus. Tail-mounted solutions for the BBJ and the BBJ Max. it can also accommodate the Ka band frequency antenna for Satcom and Sat TV. The Honeywell MCS 8000 system's integrated for these, and the antenna can either be installed standalone or in combination with other Ku and L band antenna, which are the ones on the fuselage. And as a nice little optional extra, a forward-looking HD camera can be integrated into the dome, which is a great touch. The TIOS KA installations are covered by the STCs held by Lufthansa Technik. So yeah, that's a great piece of kit, and these are very common on BBJs. Most of them have got them. The original Satcom antenna was this sort of flat plate, which was fixed onto the forward fuselage. This particular aircraft, which oh crikey, I saw this at Stansted decades ago when I was air testing another aircraft. This has had an EIS date of 2000, so you can tell that this is one of the very early flat plate antennas. Now these have got more difficulty than dome-shaped antenna at keeping a strong link during motion because they're not phased arrays. You know, they're not electronically steerable. You know, it just relies on the fact that it points almost vertically upwards to see the antenna, to see the satellite. Sorry. So these have mostly been removed and replaced with the fuselage dome or the TIOS systems. The equipment for the Satcom, because obviously you need more than an antenna, you need a receiver and a whole load of other stuff to get the data. That's stored in a cabinet in the forward cargo hold, as you can see in this photo here. Basically, what this is, it's an E&E bay overflow. And there's a whole lot of stuff goes in there. So with that cabinet and the auxiliary fuel tanks, there's actually very little room left for baggage or whatever you want to put in the hold of a BBJ-1. That's a cargo loading placard inside the hold that was installed by PATS, which of course are now loft. So inside the cupboard, that's what you've got on this. Again, no two BBJs are quite the same. In this particular installation, that you've got an auxiliary fuel control unit up at the top right there, and a cargo electronic unit down at the bottom left. With this one, I think the fuel unit is actually in the E&E bay or the forward electronic area, and the cargo electronic unit is probably in the ceiling of the cargo hold, as it is on all normal 737s. So let's take you through each of these compartments in sequence, so we can have a look at the kit in there in a bit more detail. Starting with the top left, that left-hand unit there, well, you can read it on there. It says an HS720 high-speed data unit. So for a multi-channel Satcom system, what this is, it's a high gain antenna receiver that gets your ARINC 429 information from the antenna. On the right hand side is a unit called Aircom 3000, and again these are only options. There are other makes and models are available, but with this particular aircraft it had this fit, so I'll take you through these. But this one, I say, it's got the Aircom 3000 for the satellite phone computer. This enables passengers to use portable phones in the cabin. If you've got sat phone in the flight deck as well, that's on a separate channel to the passengers' phones, and it's got a different phone number as well. Up at the top right, taking up all that space, is one little unit, which is the Jetline AR250 router by Cobham. That sends RS-232 data to the four Wi-Fi antennas in the cabin, and it's also the hub for signal distribution. In other words, a router. There's the AS250 as well, which Cobham made, which is a combined network server and router. Mid-shelf aft is the HP 720 high power amp. That boosts the power from the antenna, giving you a faster data speed because you got better signal strength to reduce the signal latency. So it improves the signal to noise ratio. On the right hand side, that's the CMA 2102 BSU. In other words, the beam steering unit. That's the box that does the magic to control the electronically steerable phased array antenna. Forward, you got the SD720 satellite data unit. That gets the data from the satellite, transforms and mixes the signal from the antenna, and sends it on to the router. And on the bottom row, there isn't really very much to see there. It's just electrical terminal blocks. But I say on some aircraft you've got the forward cargo electronic unit mounted there. So SATCOM for us in the flight deck, that's what we see, an extra button there on the audio selector panel. You simply push SAT1 as selected there, and then dial a sat phone from the McDo, and you can speak over the headset to whomever you called. Just be aware for your for the owner that SATCOM calls are expensive. Some operators have got an address book of allowed numbers, so only your ops or your main troll or what have you, so that, pilots can only call the numbers in that book to prevent crew from making personal calls at the owner's expense. Some owners are more trusting and leave the address book open. It all depends who you've got. So let me summarize all those previous slides about SATCOM and just try and chain it all together for you so you can see how it works. So on the ground, on Earth, you got the network there. The network server fires across through a terrestrial link to an Earth station. There's a dish there pointing up at at your nearest Inmarsat satellite. That's sent up along C-band. From the satellite, it beams down with Ka or L or Ku band or whatever it might be to the antenna on your BBJ. The antenna is steered by the BSU, the beam steering unit. From there, the signals go through an amp to boost the signal to noise ratio, and into the receiver, where obviously the frequency is tuned, the signals are heard and processed. Data is extracted from those signals with the data unit, and it is then sent into around the aircraft to be used wherever it needs to be. So that can be to the router for cabin internet, so for the Wi-Fi access, or for LAN ports that are in the cabin. The Aerocom 3000 for sat phone calls, and the CMU 900 for data links. So this is obviously more stuff for us in the flight deck. Your fans, fans 1, fans 2, data link, ATN, all those sort of things. Oceanic airspace, whatever it might be. Okay, so that's SATCOM summarised there. Taking a look at fuel now for the fuel systems. As I've already said, auxiliary fuel is the big thing on the BBJ. BBJ customers demand a global range. That's why they got the bigger aircraft in the first place, to be less claustrophobic, going right back to GE's vision for a large bizjet. With relatively low payloads that you have on a BBJ and the increased gross weight of the BBJ over the standard 7.3, extra fuel can be carried. Up to 9 auxiliary fuel tanks. That's in addition to your normal 3, the 2 wing tanks and the centre tanks. You got an extra 9, giving over 37 tons, 83,000 pounds of fuel. As a customer option. That is a heck of a lot of fuel. Now the particular BBJ picture there, appropriately registered N737 Echo Romeo, ER was designed for medical evacuations and charter ops, and that flew a record 6,854 nautical miles, 12,500 kilometers from Seattle to Jeddah in 14 hours 12 minutes. The aircraft still landed with 2.7 ton of fuel on board. Amazing. Amazing. That was actually over 20 years ago. The 200 VIPs, they had auxiliary fuel as well. Again, it was fitted with by PATS. They just had 3 fuel cells in the forward cargo hold, 4 in the aft cargo hold. Total fuel capacity of 53,700 pounds. So what's that, about 20 ton or so, giving a range of around about 3,500 nautical miles with full reserves. Auxiliary tanks are pressurised about 8 psi using unregulated pressure from the engine bleeder. Similar system to what we got on the NGs and the Max today. Fuel transfer to the centre tank could begin in the cruise when the centre tank had burned at least 5,000 pounds. In other words, when there was room in the centre tank to take the auxiliary tank fuel. So there you go. And kind of typically with everything in the 200, it all look very complicated with lots of sort of gauges and lights and switches and what have you. I'll fast forward in a couple of slides to show you how it looks now on the Max. It's a world of difference, much more user friendly. The auxiliary fuel tanks in the NG, so you can have up to 9. The original plan was actually to have 10 until Winglets came along, and the performance improvements of that meant you didn't need the 10th. Maximum fuel quantity there of 70,500 litres. That's 32.5 tonne. In practice, that would probably take you over max takeoff weight if any significant payload was carried. Normally limited to about, I don't know, 10 passengers or so if you're going to take that much fuel. Normally the payloads are usually low on the BBJ, so it's not usually an issue. For the BBJ2, maximum capacity is 31,953 kilograms, and BBJ3 it's 33.5 tons. That fuel gives a theoretical range in excess of 6,000 nautical miles. Very impressive numbers. During proving trials, Boeing flew a 9-tank non-winglet BBJ-1. So again, this was going back some. Around the US, circuit of 6,200 nautical miles, Delaware, Maine, Seattle, San Diego, Miami, Baltimore, and then held until they burnt off fuel to normal reserves, and then landed back in Delaware. Total flight time almost 14 hours. They got airborne with 32,250 tons and landed with 2.5 tons. So yeah, these things have got a heck of an endurance. One thing with the auxiliary fuel is that the CFG does shift a lot more than it does with the regular fuel loads of a regular 737. Now, what I've shown you here on the right is typical BBJ EFB weight and balance application, and what I've done is I've shown a load there with maximum fuel, so 31,247 on the fuel, or 68,889 pounds. You can tell by just subtracting zero fuel from taxi to get that figure. Now, the auxiliary tanks are located in the rear of the forward hold and the front of the aft hold, so they're located, toward the centre of the aircraft as far as they can be, but obviously the extremities of them is much further away from the CFG than it is on a regular 737. So that changes the CFG as the fuel is used, and you can see how the CFG changes with fuel burn. You see where I've highlighted in red on the envelope, on the CFG envelope. That white line is the change with fuel burn. So you can see it actually starts moving forward, then comes aft, quite a long way, then forward, then aft, and then back to wherever it is. So it's something that does need to be borne in mind, that you always, just because you take off in the envelope does not necessarily mean that you're going to remain in the envelope in flight. That's the thing you have to look out for. But anyway, that's all part and parcel of the job of a BBJ pilot. The auxiliary fuel control unit, as I say, that's one located in the forward hold. That's the interface between the aircraft systems, flight deck controls, refueling controls, and the auxiliary fuel tanks. Monitors the switch and valve position, quantity, pressure, air ground status, sends the output signals for valve control, and alert and maintenance messages. So that's the brains of the auxiliary fuel. But fortunately, because we've got brains like that, we don't need to as the pilots, and the auxiliary fuel system is just about automatic. It works by transferring fuel from the auxiliary tanks into the center tank. That is then fed to the engines in the normal way. So again, let me just spell this out. Fuel is not burned from the auxiliary tanks. Fuel is burned from the center tank. The auxiliary system transfers fuel from the auxiliary tanks into the center tank once there's a room vacated from the center tank by the aircraft burning fuel in flight. It's burned from the center tank. And that process is automatic. All you have to do is flick those 4 switches to auto, and it takes care of itself. You can select forward or aft tank groups if you want. Those are tank groups, by the way, so it can be controlling 3-4 tanks with each pair of switches. The forward and the aft are considered to be one group, however many tanks you've got in there. Normal practice, I say, just have all 4 switches on, and the brains will maintain the C of G balance. Forward and aft tanks just switched off when the alert light illuminates on the main panel. As I say, no pumps in the auxiliary tanks. It's just done by the fuel is just transferred by differential pressure. So it's actually cabin differential pressure, and bleed air is used as a backup to maintain a head of pressure on the auxiliary tanks, which pushes fuel into the center tank. On the NG, there's a main panel on both the captain's and the FO's instrument panel. They show the quantity and system alert and maintenance messages. The alert messages are faults which can affect the auxiliary fuel operation. Maintenance messages are for single point system faults and may require maintenance action. You cycle through all the active messages by pushing the alert or maintenance button as applicable. So you just push that and it cycles through. Note that engaging the maintenance message and anti-ATO switch in flight is prohibited. Never tried it, got told not to, so there we go. Okay, and let's bring this up to the present day, and this is what it looks like on the Max. So with each generation, the system's been sort of shrunk and simplified and improved. That's what you've got on the Max. So all of the panels that were scattered around on the NG, they combine into this one panel now. That's where the lower DU was on the NG. The alert and maintenance messages display has been removed, so previous alert messages can be inferred from those captions that you've got there, and new auxiliary fuel maintenance caption alert engineering to investigate any faults. So it's all much more simple. Again, as before, all you do, flick those 4 switches to auto and just leave it alone. For refueling of the auxiliary tanks out under the wing, when the patch is open, you've got that extra auxiliary panel. You just move that guarded switch to auxiliary tanks, and the display changes to either FA or AA, which is for forward auxiliary or aft auxiliary. Okay, let's look at the aircon and pressurization differences, or should I say differences and options. Some BBJ ones have got the option for separate forward and aft cabin temperature controls. That's because the cabin's often divided for privacy. This photo shows a Raytheon panel, and it effectively makes the aircon system function like that on the 8900 series. So what you've got is you've got trim, air and zone control, and 3 duct overheat captions, 1 for each cabin. So really this is although it doesn't look identical to, it functions pretty much the same as the panel that we got on the 8 and 900 series, rather than the old 700 series one. Low cabin altitude is a modification, but it's an option. I don't think this is standard, but I would doubt that many BBJ owners have not taken this option. It became available in 2005, and what this does is it lets the BBJ operate with a reduced cabin altitude of 6,500 feet. Instead of the normal 8,000 feet that we've got on the regular airline 737s, at altitudes up to 410. With the cabin being at 6,500 feet rather than 8,000 feet, there is a significant increase in passenger comfort. The payback for that is that the scheduled delta P is now increased up to 8.99 above 370, and in actual fact the mid-range scheduled delta P of 8.4 is now 8.44 from flight level 280 to 370. So the whole schedule has been readjusted to take account of this increased diff or low cabin altitude option. Now because of this, the max diff is reflected on the pressurization on the diff pressure gauge there, and you can see that the red line is up at 9.6, and the caution range extends from 9 to 9.6, which obviously is different to our normal 737s. Payback for that higher delta P is a 20% reduction in airframe life cycles. Now, the 737's life to 75,000 life cycles, which is a hell of a lot. That's now reduced down to 60,000. Also, any repetitive inspection cycle intervals are reduced by half. But the thing is, with the BBJ, they're always such low hours and cycles aircraft that they never get anywhere near those limits. So it really isn't any penalty at all for a BBJ operator. And of course, the customer feels much better. He arrives at destination feeling refreshed. Doesn't feel like he's been wrung out for the last 10 hours or whatever it's been, because the cabin altitude has been so much lower. High altitude landing is another option. This enables operations into airfield elevations above the basic 8,400 feet that we've got on the regular 737s. With this, you can operate into airfields of up to, well, it depends. There are several options here. 10,000 feet is one option on the 800. 14,500 feet is an option on the 700 series, and for the Max 7, they've got an incredible 15,500 feet airfield elevation, and that's known as ultra high altitude landing field option. So changes for this are the addition of a high altitude landing selector switch, which you can see in the photo on the right hand side there. Cabin altitude warning horn will activate at, well, it depends which mod you've got, which version, but 12,650, 14,000 or 15.2. Obviously for us it normally operates at 10,000 feet. An extra hour of emergency oxygen is installed. Winglets are mandatory because, you know, for the performance gains. 10 minutes of engine out toga thrust is highly recommended. Last thing you need is an engine failure of V1 at 15,500 feet without having 10 minutes to climb away. And carbon brakes are recommended for stopping, and obviously your V1 calculations. Okay, so a quick look at the hood and the enhanced vision system. Now again, all the fine detail of this, if you want to know more about it, see my video on hood and EVS. But just a quick sort of recap on how it tied in with the BBJ. All BBJs since 2001 are fitted with hood as standard. Now some also have EVS, but EVS isn't standard. Now for the original BBJ 1 and 2s from September 01, it was the HGS 2350 system. From May 2003, it was the HGS 4000 system, and for the Max, it's the HGS 6000 system. And I say that's baseline standard. That's what the aircraft comes with. With EVS, which is the enhanced vision system, this isn't standard, but you can see which aircraft have got it because they've got an EVS camera. Some of the early ones had the camera here, which was mounted ahead of the nose gear. That gave that was less than perfect because there's a parallax error there because of the distance between that and your eye level. You can see it's got to be, I don't know what, 6 or 8 feet difference between your eye level and that, so that can create problems. After a few years, the camera location was moved onto the top of the radome to give us as close as possible a view to the pilot's line of sight. That unfortunately means that the radome has to be specially made, and that's done by Nordam, so that's not an original Boeing part. So it's not interchangeable with standard ones, or indeed easily sourced if a replacement's needed. So if you get a bird strike that damages the radome, and you've got one of these, then you've got to get onto Nordam to get another one sent to you, which, you know, is going to take a couple of days. Whereas if it's a regular radome, there may be one already in the country somewhere. The glide slope antenna within radomes moved down to accommodate the camera that would be within it there. The display of the EVS, you switch it on, the system on, through the McDo with the ISU status toggle, and then you switch the display on through the hood with the toggle switch on the yoke, which you can see there. That IR camera information is then passed on to the HGS computer, which adds the information to the normal symbology, superimposes it, sends the signals to the overhead unit, and displays it on the combiner, which you see on the head-up display. There is also a head-down display option as well. I think the P8s have got this. It could be optional on all, but I'm not quite sure. Certainly, I've seen it on most of them. You can do this basically to verify the EVS availability and for enhanced outside awareness during taxiing, if you wish. No, there's no HUD symbology on the lower DU. That's just the raw EVS, which is displayed there, and you select it there with the lower DU video selector. The other positions which are in up there are for CCTV cameras. The 200 did have EVS as well. Again, it was an optional extra. There weren't that many fitted with it, but it was there. Again, it was the old position in front of the nose wheel. So again, it wasn't marvelous due to parallax error. As far as I know, the 200 didn't have the radome mounted camera. and selection of it was with a couple of push buttons on the instrument panel. That really I put in just to prove that yes, the EVS was available on a 200. Most people you tell this to just don't believe you, but you can see it actually there. Okay, FMC options. Again, just to make the point, the BBJ, one of its big differences from regular airline 737s is that almost all available options are standard on a BBJ. That philosophy extends right the way through to FMC options, hence the long list of activated options shown here. Most airline options pages are about 2.5 pages, and here you can see we got 3.5. And there's probably more than that now with update 14 or 14.1 as we're up to now. Looking at a couple of the big ticket items, Polar Nav was one. This capability was added as an option for the 737, primarily for the BBJ, because it was the BBJ that had the very long range. Normal 737s don't have a very long range because of the payload, so they don't normally operate polar routes. But with your BBJ, if you've got 12 to 14 hours endurance or range, then you may be looking at going polar. And for that you need the polar nav. In other words, the ability to go into true nav. So there's a heading ref switch on the aft overhead panel, which switches the heading reference from normal to true, magnetic to true. And the AFM operating latitude limitations are removed. At the same time, GPS track data was added to the progress page to give aircraft heading data at the north or south poles if both IRUs fail. That was actually fitted to all aircraft, whether they had the polar option or not. That's why we've got that on the progress page now. Another standard feature on the BBJ is the control surface position indicator and the combined tyre pressure and brake temperature monitoring system, the TBMS. I've shown it here on a BBJ Max. Max BBJ. Very nice system. The control surface position indicator, I've flown that on regular airlines 737s. But the TBMS I've only seen on BBJs. And finally, a look at other options, so sort of washing up whatever else there might be. Alternate nav system, and this, for those of us who used to have alternate nav on the classics, which if you remember came off the IRS, this is an updated system for the NG, which comes from the GPS. So if you get an FMC fail, then you've got an alternate navigation system from GPS. I'm pretty sure the military 737s have got this, the P8 family, and of course the BBJs. The FMCS, CDS and DME all on the standby bus for increased redundancy and backup for those long polar trips or long ETOPS trips. FANS 1 became standard from 2006, which you see is the ATS data link option. GLS Cat 1 came in 2012. ETOPS with APU on demand from 2013. APU on demand, for those of you who don't know it, this is basically having the APU starter generator. I think it's a different part number to the regular starter generator, and it's got a more frequent maintenance inspection interval time. I believe that's pretty much the nub of it. And what that means, sorry, overlooking the obvious there. So APU on demand, basically, it's I say proof. What's the word I'm looking for? It's the guarantee to you as crew that your APU will start when you need it. Um, I've done some transatlantic trips on the 737 where you get to destination and you can't start the APU because it's cold soaked, and it just won't have it. So APU on demand, as I say, it's got a better starter generator, it's got a better maintenance, and I think you have to demonstrate that you can start it after a cold soak every so often to keep the ETOPS license. That's what that's about. Other options: 188-gallon water tank, including a 34-gallon hot water tank with UV sterilizing units. That's done in finishing. Sorry, increased cabin soundproofing, again done in finishing. Long-range passenger options system. So that's 4 bottles with therapeutic cabin outlets, and 2 observer seats on the jump seat. So there's those. There's actually a few more as well, which have come in since, and a lot of smaller options as well, more minor things. But that's the main things. That's it. That you now know as much about the BBJ as I do. As always, if you've enjoyed this video, give it a like, subscribe to the channel if you haven't already done so, and share amongst your friends. If you're feeling particularly benevolent, and appreciate the work that's gone into these videos, consider buying a copy of the book. It's got all these details in, and it's a little reference for you to take with you on your flight. Thanks very much for watching.